Alright guys, so you have got the other answer keys already for the percent error practice and that average atomic mass practice, but I want to make sure and go through these metric conversions, especially because of the quiz. So if you have any questions you need to ask me, I'll be sending this to you as soon as I can, but just want to start rolling with these. Now these metric conversions, they go from what I'm going to look at you and tell you is easy. And it works its way to what I'm going to tell you is hard. If you can do the back sheet, you're doing just fine. If you're struggling with the first couple ones, then we really should have already had a talk. But let's look at it and let's get it rolling. Now, with all of these, I am going to do my method. I'm not going to be the person to do both ways. In this video, you guys seem to like my method the most. So you need to make sure on these prefixes, all of these are fair game, all the way from exa to atto. They're all fair game, but what I want you to remember is don't worry about the meanings, worry about the symbols, the prefix names, and these exponential values over here. That's the key and the trick to getting everything working with my method. So let's get rolling with this. Now, because you have that quiz, you should be getting to the point you don't need that prefix, magic prefix handout that I gave you, because you're not going to get it on your quiz. So let's look at the first one here. So the first one is 76.258 M, stands for meters, equals how many megameters? Find what's the same in both sides. So I have an M and an M. So I now have found my base unit. It doesn't matter if I know that stands for meters or not. Step 2, write it down. 76.258 times 10 to something or another, that exponent. We're going to find what that exponent is. That's the difference in our prefixes. So let's find the difference in our prefixes. Well, first here I just have the base unit. So that is a 0 minus, because we're finding the difference. The prefix here is M, a capital M, stands for mega, and that exponential value is 6. So 0 minus 6 equals negative 6. Now if you're looking at your other steps, we would be looking here. The next step would be multiply by the exponent that is on the units. We do not have exponent on our units, so we are not multiplying. Then we would look to add the exponential that we started with on the number. There's not one there, so we are done, and it is negative 6. Let's look at number 2. Number 2 is 125.45 meters equals how many nanometers? So mark what's the same. M is the same, M is the same. Those are the base units. Write the number down, 125.45 times 10 to something or another. We got to find the difference in these prefixes. So first, the base units of 0 minus nano is N. You should be remembering that nano is negative 9. Anytime you subtract a negative number, it's like adding the positive. So add the positive, which will be equal to 9. There's no exponent on the unit, so we won't have to multiply. And we didn't start with a scientific notation number, so we don't have to add anything. So our answer is 125.45 times 10 to the 9th nanometers. Now let's move to number 3. I like number 3 as a really good example behind why know the method, trust the method. When you look at this one, we're going to write the number down, 19.47 times 10 to something or another. Find what is the same. A lot of you are falling into this trap of just saying that that last letter is the same. You won't get 2 prefixes on one. I won't do that to you. What's the same? I have a PA over here and I have a PA over here. If you don't know what PA stands for, that's okay. It doesn't matter. This is here because this is what people like the ACT, SAT developers, they do little stuff like this to catch you up. Well, I don't know what that means, so I don't know how to solve the problem. You do. Why? Because you know the prefix is kilo, and we're going to femto. That's what matters, is those prefixes. So let's trust the method. Let's start with kilo. Kilo is 10 to the third, so 3 minus femto, and femto is negative 15. So that's adding a positive 15, which is 18. Now there's no exponent on the units, so I don't need to multiply. And there is no exponent or scientific notation with my number, so I don't have to add anything I originally start with, so the number is 19.47 times 10 to the 18th power. Please do not get tripped up on that. I don't want you falling into the trap of, whoa, I don't know what that means or what that stands for. Don't worry about that. You just need to worry about making sure you can change the prefixes. So, let's go back here to number 4. Let's write the number down. Times 10 to something or other. We're looking at it. We got to find the difference. What's the same? L and L. Those are the same. I'm zooming in just a little more. L and L are the same. So I'm trying to find the difference in N and capital G. So N is nano, which is 10 to the negative 9th, minus giga, which giga is 10 to the positive 9th, so minus 9. Negative 9 minus 9 is negative 18. There's no exponent on the unit, so I don't have to multiply. I didn't start sign notation, so I don't have to add anything. So this one is just 76.258 times 10 to the negative 18 power. Let's look here at number 5. Number 5 adds something in now. We're changing. I've done what I've done before to you. So just like we did there in number 3, don't get caught up on what these units stand for. Trust the method. You're worried about the prefix. dB and dB are the same. So we're changing between mega and tera. Now I added something else here, so if you're getting tripped up here, you're messing up on a step. I added a scientific notation number to start with, but still follow the steps. Step 1, write the number down. 47.25 times 10, but leave the exponent blank. That's that something or another we're going to have to find. So mega, that's what capital M is, mega. That has us at 10 to the 6, so that is 6, minus tera. Tera is 10 to the 12th. 6 minus 12 is negative 6. So we found the difference at step 2. Step 3, we'll take that number that we found the difference, we will multiply it by the number that is the exponent on our units. So, there's no number there, so we skip that step. The last step would be to add any number you started with, the exponent of a scientific notation number that you start with. And that is what I'm talking about. This is where that step comes in. Right here. You see this 8 hanging out there? That 8 is what we add here. So I'll add 8 on, which gives me 2. So it's 47.25 times 10 to the 2nd power. That's what I'm saying. Alright, don't be so concerned about that. Let's go to number 6. Number 6. Write the number down. 2.478 times 10 to something another. Let's look. A is the same. We're finding the difference between peta and centi. Peta is 10 to the 15th, so 15, minus centi, which is negative 2. So add a positive 2, that gives me 17. There's no exponent on the units, so I don't multiply. But I did start with an exponent. I started with that negative 12, so I have to add the negative 12, which will give me 5. So 1.478 times 10 to the 5th power. Let's move to number 7. Number 7, the little m's are the same. So I'm finding the difference between pico and milli. So let's write the number down. That's step 1. Step 2, find the difference. Pico is 10 to the negative 12th. Subtract out milli, which is a negative 3. So add a positive 3, which is negative 9. There's no exponent on the units. So there's no exponent here, there's no exponent there. If we can see it better now. There's no exponent on the unit, so I don't multiply, but I do need to add this 712 because I started with it. I do little things like this to get you tripped up. Don't be caught up that that's such a huge number. Follow your steps. Trust your steps. So 9.745 times 10 to the 703rd power. Number 8 is a nice little trick I love to use. Find what's the same. There's an M and an M. A lot of people are going to skip this and they're going to look and say, this is milli. No, that's the base unit meter. Do not skip that. So I'm going from giga to a base unit. So let's write the number down. So now I'm looking at the difference between giga and the base unit. So I do the math. Giga is 10 to the 9th. So 9 minus the base unit, which is 0. So that is 9. There's no exponent, so I don't multiply, but I do have to add this negative 174. So 9 minus 174 gives me a negative 165. So 2.478 times 10 to the negative 165. Number 9 is huge. This is my big trick. And like I said that day in class whenever I taught it, it's the trick I will literally leave in my pocket. I'll always have this trick to pull out anytime I can. Take a look at the units. So what I've been doing, I've been marking what's the same. These are not the same. And how I know that is looking at the exponent. So I start here and I'm like, whoa, this is cubed. I go over here and there's nothing there. It's blank. Take a look. We went from cubic centimeters to milliliters. Remember that 1 cubic centimeter is equal to 1 milliliter. That's where that identity comes from, and I told you, we will use this. You literally copy and paste the number. Doesn't matter what number I put. In this case, it's 76.258. I copy and paste the number. There's no times 10 or anything in that case. That's the only exception. Copy and paste. Number 10. Let's look at number 10. I hope you guys caught that on number 9. I really, truly hope you caught that. Number 10. I have L and L are the same. Now this is where I add something in. I've added another step for you to practice with. So let's write the number down. 1,257 times 10 to something or another. I'm trying to find the difference in nano and giga. But here's the thing, it's to the second power. We're going to handle that here in a second. So, step 1, write the number down. Step 2, find the difference in the prefixes. Whenever you look at nano, nano is 10 to that negative 9. Subtract giga, which is 10 to the positive 9. So that is negative 18. We found the difference in step 2. Step 3, multiply by any exponent on the units. You've heard me say that a lot in this video, but this is the first time it applies. These are squared, so we have to multiply by 2. Because the unit, this you multiply by the one that's on the unit. So negative 18 times 2 is negative 36. And then you would add whatever exponential value you started with. In this case, we don't have one, so it's just negative 36. If you're doing good at this point on all of these, that's awesome. Okay? I want you to know that. That is great. Now, what we're going to do, I'm going to the back page. Let's move it to the back. So here is the back, and this is where it gets harder. And this is where it really tests you. If you can do the back page, I'm confident you're going to do well on the metric conversions that you're going to have to do on the quiz. Alright, I think we're done focusing. Sweet. So, let's start it off. Mark what's the same. dB. Do you know what dB stands for? Doesn't matter. Why? You need to know the difference in the prefixes. Mega and tera. Let's write the number down. 19.4 times 10 to something or another. So let's go with mega for step 2. We're going to write down, we're going to find the difference. Sorry, step 1 is write down the number. Step 2 is find the difference, which is what we're going to do now. So mega is 10 to the 6, so 6 minus tera, which is 6 to the 12th. So 12, that equals negative 6. 6 minus 12 equals negative 6. Now you multiply by anything, any exponent that's on the unit. In this case, I'm squared. So we multiply by 2, which gives us negative 12. Now you add any exponent that's on the number that you started with. So how we have this scientific notation, and this is times 10 to the 87th, that's where this 87 comes in play. So now we're going to add this 87 to this. Whenever you do that, you should get 75. I did that in my head. I'll punch in a calculator just to make sure I'm right. 75. I definitely do not want to be wrong on a YouTube video. So there is the answer for that one. Now let's move to the next one. These, yet again, are where it's getting real deal. So the step we're looking at, mark what's the same, A is the same, A is the same. Find your prefixes. Write the number down. Step 1, 5.258 times 10 to something or another. Now, step 2, find the difference in the prefixes. First one we have is peta. Peta is 10 to the 15. 15 minus centi. Centi is 10 to the negative 2. So minus 2 is the same as adding a positive 2, which equals 17. Now from there, we look to multiply by any exponent that's on our units. In this case, we have a 3. So times 3. I'm going to have a calculator. You can use a calculator tomorrow. You just won't have the prefix handout. So 17 times 3 is 51. Now we add any exponential value in a scientific notation that we started with. So we're going to add to this negative 128 right there. So negative 128, we're going to add and get negative 77. So 5.258 times 10 to the negative 77. Going to number 13. Number 13, picking up the pace a little bit. M's are same, P and M, so pico and milli. Write my number down. So pico is 10 to the negative 12. Milli is 10 to the negative 3, so minus negative 3, the same as adding a positive 3, gives me negative 9. I'm going to multiply by the 2, give me negative 18. If I'm going too fast, it's a video. Stop it. Run it back. Then I want to add to that 412. I'm just following those steps that I went over and we've been using the whole time. You should be able to roll through these now. Now let's look at the next one. I have M. Oh, there's only one M, so that means base unit. So I'm going to find the difference in giga and the base unit. Giga is 10 to the 9th, so 9 minus 0 for the base unit equals 9. I'll multiply by 3 because my units are cubed. They give me 27. Then I'll add a negative 74, which gives me negative 47. So 97.847 times 10 to the negative 47. Next one. Next one. I have centimeters and milliliters. Oh, centimeters cubed and milliliters. Copy and paste. You can't even see that. I'm getting carried away. Centimeters cubed and milliliters. Copy and paste the number. So 12,578. I'm done. It's that simple. Watch for the trick. I'm telling you, you're going to see that trick. And the last one. 1.457 nanoliters squared equals how many gigaliters squared? So liters and liters are the same. Nano and gigas, what I'm trying to find the difference in. Nano is 10 to the negative 9 minus giga, which is 10 to the 9, which will give me negative 18. So then I multiply by the 2 that's on the units, which gives me negative 36. I add what I start with. There's no exponential value. There's no scientific notation, so I don't got to worry about adding anything on that case. So it's 1.457 times 10 to the negative 36 power. If you have any questions on this, you should have already asked me and spoke with me. Message me on Remind. I will help you as much as I can. Please, 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 please make sure you know how to do this. Even if you don't know how to do it right now for this quiz, you are going to need it throughout the rest and remainder of this class. So please, come ask me. Come speak with me.